Okay, so here are some notes on how to do long division with polynomials, and it's basically a process, so I'm just going to walk you through. This whole dumb monkey sometimes burp is just a nice way to remember the order in which you do things. The D, divide, multiply, subtract, bring down. So what we're doing is we're taking x minus 5 and we are going to divide it into x squared plus 3x minus 9. So the way you start is you look at the first terms and you divide them. So we are dividing x squared by x, which means we get an answer of x. So you put that answer above, and then what you always do, whatever that result is, that gets multiplied by the original divisor. So that's going to give us an answer of x squared minus 5x. And now we do subtraction, but rather than subtraction, what I recommend you do is change your signs, because you have to distribute your subtraction. So this becomes negative, that becomes positive. So you get 0 in the first term, you'll always get 0 in the first term, 8x, and now we're going to bring down our negative 9. And once you're there, you then start all over again. So we're dividing the first term by the first term, so now it's 8x divided by x, and the answer is 8, which goes upstairs. And then we always multiply that 8 by our divisor, so that's going to give us 8x minus 40. And then we go through and change signs. So change your signs. And that means I have 40 minus 9, which gives me 31. And that is, there's nothing more to bring down, so that is called the remainder. But now, the way we write the remainder, since that's positive, it's plus 31 over the original divisor. And that is how we would write the final answer from the division. Okay? So you can kind of keep track of your work off to the side if that helps, or if you've got the process down, you don't necessarily have to write that down. So let's do another one here. So notice I have a little word of caution. Be careful with the negatives when you're changing your signs, and if you are missing a power of x, you need to put a placeholder in there. So notice in this one, there is no x to the 1 term. So when we do our division, here we have x plus 4, we're going to write out 3x cubed plus 10x squared plus 0x minus 22. Because we need that placeholder, which will come clear as we're doing the problem, because you need some to be able to add like terms. So we start off with division, that's your divide, your D. You are looking only at the first term, so 3x cubed divided by x, and that gives you 3x squared, which you put up on top. And now we multiply that by the original divisor. So that gives me 3x cubed. It will always be that way because you set it up to be exactly the same. But now that becomes plus 12x squared. And so then we change our signs. So this becomes negative, and now this becomes negative. So 10 minus 2 is going to be, 10 minus 12, I'm sorry, is a negative 2x squared. And now we're going to bring down our 0x. So plus 0x. And we start the process all over again. So we divide the first terms. So we have negative 2x squared divided by x, which is a negative 2x. So minus 2x. And then we always multiply that by the original divisor. So that's going to be a negative 2x squared minus 8x. Then we have to go through and change our signs. So this will become positive, and this will become positive. So we add those, and notice you're always going to get 0 for the first term. So there's 8x, and in this one, we have something more to bring down, minus 22, which means we have to go through the process one more time. So we divide the first terms. 8x divided by x is 8. So this is plus 8. We multiply that 8 by our original divisor. So that's 8x plus 32. So we're going to now change the signs. And so that gives us negative 22 plus a negative 32 is a negative 54. That will be our remainder. So minus 54 over x plus 4. So you would write your final answer as 3x squared minus 2x plus 8. Notice the degrees go down by 1. Minus 54 over x plus 4. So it's the same process you do when you do long division with numbers. It just seems a little less foreign because of all the x's and like terms that you have to keep track of. Don't forget your placeholders. But it also takes up a lot of space, so we have a nice little shortcut on the next page. So now I'm going to introduce you to synthetic division. Synthetic division is where you're taking the root. Remember when we factor something? So if I have x minus 3 and I set that equal to 0, the solution is going to be the opposite of what's in the parentheses. So we call that the root. Okay, so we're going to take the root and we're going to put it in a little box here. Then we're going to take the coefficients of what we're trying to divide into, and we're going to write those out without the x and put this plus in this line. And then we're going to go through this process down here. So I think the best way to kind of show you this is demonstrate it. So in this first example, my root is going to be 8. Like if I set x minus 8 equal to 0, the root is 8. So 8 is going to go into a little box. I'm going to pick off my coefficients. So 1, negative 5, negative 24. I write a plus and a line. Okay? So the first thing we do is bring down the lead coefficient. That was 1. So we bring it down here. And then we're going to start this process of multiply and add, multiply and add. You multiply that lead coefficient by r. So 8 times 1 is 8. You put the result on the line and you add downwards. So 8 minus 5 is 3. Now you repeat. So 8 times 3 is going to be 24. And then you add, and that gives us 0. So we have 0 for a remainder. When you get 0 for a remainder, it means your result actually factors in, or the original dividend was factorable. But okay, so right now all you see are numbers. What does that mean? Okay, how you write your answer is you look at your original, which was x squared, that we divided it by 1 power of x. So this comes down a power. So this is 1x plus 3. And of course we don't really need that 1. I'm just emphasizing it's there. So this is our answer. So you're putting back your powers of x, but you're starting 1 power less than what you started with. Okay, so you rewrite the result 1 degree less than the original. All right, let's try another one. So notice here you take your x plus 4. If I were to set that equal to 0, my root would be a negative 4. You're always pulling off the opposite. So here's negative 4, and then we're going to write out our terms. So we have 3, 10. Notice I'm missing a power of x, so I need a placeholder. And then negative 22. And we draw our line with our little plus symbol. And we start off. You bring down your lead coefficient, and you always start by multiplying the lead coefficient times that -4, which is a -12. And so that goes here, and we start to add. 10 minus 12 is a -2. And then we multiply again, so we have +8. And we add, so that's going to be 8. And we go again. 8 times -4 is -32. And when we add that, we get -54. This was the same problem we did on the other side using long division. So if you look back and compare, this is a lot less space. So how do we write our final answer? Notice that we started with something cubed. So now we're going to write this in powers starting with 3x squared, 1 degree less, minus 2x plus 8. And our remainder is always this last term, so that'll be minus 54 over x plus 4, which is exactly what we got on the other side. Okay, so it's a really simple process. You just kind of have to do it a few times to get used to the sort of the structure of it. Okay, last little bit was this idea called the remainder theorem. So notice that we've been focusing on what our remainders are. Remainder 0, -54. So why we care about the remainder is if you do get a remainder of 0, it means you can factor the equation. Or, I'm sorry, the expression. So sometimes we don't want to go through the whole synthetic division to get the remainder. We just want the remainder. So there's a fast way to do that. And I'm going to kind of demonstrate why we know this will happen. So let's take this first problem down here, number I. And here they've given us the root, so we don't have to solve for it. Our root is 2. So we're going to synthetically divide into this. So we have a 5, we have a 2, we don't have a squared term, -20, -6. Okay, and then we put our plus. So you bring down the lead coefficient and you start, it's going to be multiply, add, multiply, add. So multiply against the 2 is 10 and add. Multiply against the 2 and add. Multiply against the 2 and add. So this will be 28. And then multiply against the 2, that'll be 56. Minus 6 is 50. So there's my remainder. So I know this wasn't factorable, but there's a faster way than even doing that. If you just take what that root is and plug it in, so you have 5 times 2 to the 4th plus 2 times 2 to the cube minus 20 times 2 minus 6, and again you have calculators. So this is 5 times 16 plus 8 times 2 minus 40 minus 6. So 80 plus 16 is 96. 96 minus 40 is 56. Minus 6 is 50. Okay, so you can see you get exactly the same answer as your remainder, which is a really fast way if all we care about is finding the remainder. So why do we care? Well, let's check it out in this next one. Let's find out what the remainder is. If I plug in -3, and again, be careful with your negatives, keep them in parentheses. So plus 3 times -3 cubed minus a -3 minus 3. So when we simplify this out, -3 to the 4th is like 9 times 9. And this is -27 times 3, so that's a -81, plus 3 minus 3. So this remainder is 0. What that means, since our root was -3, it means that x plus 3 is a factor of the original polynomial. And that's going to then help us factor this and solve for all the other zeros. Okay, so a remainder of 0 means that whatever you divided is a factor of your polynomial. Okay, And hopefully that helped, or if I went too fast, you can go back and listen to this again.